see. So first we'll go for resistors. So some good options are available in CMOS. One is using polysilicon interconnect. So we are going to use a polysilicon interconnect because it is going to provide more resistivity compared to a metal. Okay, so instead of having a metal, we are going to use a polysilicon interconnect material. And mostly nowadays, poly materials are very good and used, and they can significantly reduce the resistance. Even small value of resistance can also be fabricated using the poly components. Okay, so poly interconnect can be used to even fabricate smaller value of resistance also. So poly is appropriate mainly for small value resistors. Since poly has a tendency to reduce the resistance, I can use this poly to fabricate smaller value of resistance. But tolerance is very poor, and temperature coefficient. It is defined by for rate of change of temperature. What is the rate of change of resistance? So it is 1 by R rho R by rho T. For the variation in temperature, what is my variation in resistance? And they say that for poly, that tolerance is very poor, and the temperature coefficient is also going to be very large. And you can see it is 1000 ppm per degree Celsius. For 1 degree increase in Celsius, the resistance value increased by 1000 parts per million. So unsilicated poly is going to have a higher resistivity, and the temperature coefficient is going to be almost zero. So it is not going to have any variation in temperature, and it is usually not tightly controlled. So unsilicated poly, if available, it can be used, but again, it is also going to have a very loose tolerance of 50%. Previously, the poly was having 30%, but now the tolerance level is 50%. So I have to think what I have to compromise for making my component work at high frequency. That is left to the designer. So advanced bipolar technologies are going to use only poly emitters. So poly resistors are also an option which is available in advanced bipolar technologies. So in addition to the moderate temperature coefficient, poly resistors will have low capacitance per unit area and the lowest voltage coefficient of all the CMOS technologies available. So for all the technologies, they say poly resistors are going to significantly perform better because they are going to have a low parasitic capacitance. The reflection coefficient is also going to be low, and it is best among all the CMOS technologies. So resistors made from source drain diffusions can also be used. You are going to see the different innovative methods by which I can fabricate resistors. So far, we have seen poly, unsilicated poly, and poly resistors. So now we are seeing that if we are going to create a resistive effect from source drain diffusion, then that is also going to be helpful for me. So the resistance is going to be, the temperature coefficients are going to be very similar to those of polysilicon and unsilicated silicon, but the lower temperature coefficient can be achieved with higher doping. So if you dope heavily, you can achieve lesser temperature coefficient. So, but because of these, you might see a jump in the parasitic capacitance value, and the voltage coefficient which was low might increase if you start heavily doping your poly resistors.